Hi all. So in this video we'll be starting off with the sixth module, that is the control logic design. In the fifth module we have seen how to design a processor, and inside the processor we separately saw how to design an arithmetic logical unit, how to design a shifter, how to design an accumulator, etc., and all together how to design a processor. So in this sixth module we'll be focusing on how you can design a control logic. Okay. So this diagram shows a simple relationship between the control and the data processor, that is the control logic and the data processor. The data processor is nothing but our general purpose processor that consists of a set of registers and also that can perform certain operations. And only when the control logic initiates a specific operation, so can a data processor perform that operation. So it is based upon the control logic's initiation, each and every operation that happens in a data processor. So whether it is a read operation or whether it is a write operation or a move or a copy, it could be anything, but it need to be initiated from the control logic. Okay. So the processor needs to update the status condition to this control logic also. That is whether the processor is ready or whether the processor is underperforming some other operations like that, or whether it is busy. So based upon the status condition and based upon any other external inputs, the control logic will initiate the micro operation. So this is a symbol diagram that shows the relationship between the control logic and data processor. All what we are going to discuss in this module is regarding the different methods by which you can actually design a control logic. So there are 4 methods by which you can design a control logic. The first method is one flip-flop per state method. Then you have a sequence register and a decoder method. Then you have a PLA control method, and then you have a microprogram control method. Okay. So before that, going into that detail, let me just come again and say one more point regarding control logic. This control logic circuit is a sequential circuit. The reason why you call it a sequential circuit is that whatever micro operations that are being initiated, it happens in a sequence. That is one after the other. That is initially if it is an load operation, then after the load operation, if it is successful, the next operation that need to be carried out might be an addition operation. Then it could be a move operation. Likewise, the operations need to be performed in a sequence. For that reason, the control logic is a sequential circuit. So when you are going to design, you have to design a sequential circuit. For designing a sequential circuit, these are the 4 different possibilities there. So we know that you can design it theoretically by making use of a lot of flip-flops and a lot of wires. So these 2 methods, the first 2 methods, make use of a lot of flip-flops, a lot of integrated circuits and a lot of wires. Hence these 2 methods are called as a hardwired method, because any modification or updations that need to be done to the control logic is done through rewiring. That is, you have to take out the chip, you have to insert a new one, or you have to do the modification and then rewire it. So every time when a modification need to be done, a lot of rewiring is present in these 2 methods. Okay, and this method uses a simple scale integration and a medium scale integration. Okay, these 2 methods uses an SSI and MSI. So not simple scale, small scale integration and medium scale integration. Okay, and then the control unit implemented with SSI and MSI devices is said to be hardwired, as I've already said. Then the next 2 method, that is the PLA control method and a microprogram control method. These 2 methods, in order to perform an alteration or a modification, it can easily be achieved in these 2 methods because they make use of a programmable logic array or a read-only memory. They have a ROM or they have a PLA inside that circuit. Okay, so it doesn't mean that they are hardwired. So nothing is connected through wires in that 2 method. So whenever a modification need to be done, you can just take out the ROM or that PLA array. You can perform that updations and keep that ROM back in that position. So that is how updations or modifications are being done in these 2 methods. So throughout the 6th module, we will be discussing about in detail about how one flip-flop per state method can be designed, how a sequence register and decoder method can be designed, PLA control method and a microprogram control method can be used for control organization, and then we'll see the disadvantages and the advantages of each of these methods or each of these control logic design mechanisms.